Hello, welcome to Lesson 26, Solving Inequalities. During this lesson, we will learn how to solve equalities and graph them on a number line, as well as how to graph an inequality in slope-intercept form. Before we begin, let's look at our key vocabulary word. Inequality, a mathematical sentence that shows the relationship between quantities that are not equivalent. And there are four inequality symbols that I'd like to introduce you to. So the first one is our less than symbol. So less than. Then we have greater than. We have less than or equal to, denoted by the line underneath the less than symbol. And we also have greater than or equal to, again denoted by the line underneath the greater than symbol. So we've got less than, greater than, less than or equal to, greater than or equal to. So those are our four inequality symbols. Let's look at our next slide. You solve inequalities the same way you do equations. Perform the inverse operation. So, reflecting back on our inverse operations, the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. And the opposite of division is multiplication. So, we're going to practice solving some inequalities. I have them listed on the board. Okay, so there are mainly one-step inequalities. When we get to the bottom, we have a two-step inequality. But before we begin, I want to talk to you about these symbols. When we graph them on the number line, there are special rules we have to abide by. Let's look at the next slide. When graphing the solution on a number line, less than and greater than have open circles because the number is not included in the answer. An example is x is greater than 7. X is not equal to 7, it is greater than 7. When using less than or equal to or greater than or equal to, you're going to have closed circles because the number is included in the answer. And in the example given, x is greater than or equal to -1, x is greater than or equal to -1, it's included in that answer. So let's practice solving the inequalities that we have on the board. So our first one is -4 is less than x divided by -3. So we're going to solve this the same way we would a one-step equation. They're dividing by -3, so I'm going to multiply both sides by -3. I'm going to bring down my positive 12. I'm going to bring down my x. But there's a special rule when you're dividing or multiplying by a negative number. Here, notice I'm dividing by -3. When you're dividing by a negative number, you have to reverse the inequality symbol. Okay, so now we have 12 is greater than x. I want you to get into the habit of being able to read it another way also. If 12 is greater than x, then x must be less than 12. Okay, notice that our inequality symbol is pointing to x in the first answer, and it's also pointing to x in the second answer. So remember that rule. Whenever you're multiplying or dividing by a negative number, when you're dealing with inequalities, you have to reverse the symbol, okay? All right, so on my number line, if I was going to graph x is less than 12, okay? I like to put at least 3 numbers on my number line, at least 3. Since the answer is 12, I'm going to go one below and one above. I'm going to put my circle on 12, and I'm going to go back to the rule. For less than or equal than signs, I simply leave that circle open, and it's saying x is less than 12. So I would shade the numbers that are less than 12. Here, 12 is greater than x, which means x must be less than 12. And that's what you're always trying to shade on your number line. You're shading what x is. Don't look at the symbol and shade in the direction of the symbol, especially if your variable is on the right-hand side. That's why it's best if you want to rewrite it, x is less than 12, and then once your variable is on the left, then you can use that little cheat sheet. It's pointing to the left, I can shade to the left. But that's only if your variable's on the left. Remember that. Okay? Let's look at our next inequality problem. So we have -2x is greater than 12. Again, you solve these inequalities by using the inverse operations. They're multiplying by -2. I'm going to divide by -2. And there's that rule. If you multiply or divide by a negative number, you have to reverse the symbol. My negative number is beside of my x. I'm multiplying that x by -2. So I'm going to go ahead and reverse my symbol. Brought down my x. Do the math. X is less than -6. Notice my x is on my left. So when I plot this on my number line, I'm going to use -6, -7, -5. Okay? So look at what we've done. -6 is in the middle, -7 because you're getting smaller, and -5 would be above. So I'm going to put a circle on -6, and it's saying x is less than -6, so I would shade the numbers that are smaller than -6. Is -7 smaller than -6? Yes. Okay, not too bad. So let's move on to our third example. Our third example is 7 times y is greater than 49. Okay, I do not see any negative signs. We're not multiplying by a negative number, so I'm going to use my inverse operation of division, do the math, and I'm left with y is greater than 7. I need 3 numbers on my number line, so I'm going to have 7 in the middle. I'll have 6 below it, 8 above it. Put my circle on my 7. Open circle because it's a greater than symbol, and I'm going to shade to my right. Again, if you want to rewrite that just for practice, if y is greater than 7, then 7 is less than y. Okay? You need to be able to read it 2 ways. Okay, and our last, I'm sorry, not our last example. We have 2 more to go. All right, so x minus 8 is less than 11. So what's the opposite of subtracting? It is adding. All right, I'm left with x is less than 19. Okay, so I'm going to put my 3 numbers on my number line. 19 would be in the middle, 20 is above it, 18 is below it. Again, I would have an open circle because of my less than symbol. X is less than 19, so I would shade the numbers that are smaller than 19. So far, so good. Okay. And our last one is a 2-step inequality. Not a big deal. Okay. But our symbol is different. Notice we have the equal sign. That means we're going to have a solid circle. Okay. So I'm going to add 2 to both sides to get rid of that. Bring down my 2m, bring down my symbol, bring down my -8. -10 plus 2 is -8. Divide both sides by 2, and notice I'm dividing by a positive number. I do not reverse the symbol. M is greater than or equal to -4. So on my number line, I would have -4, -5, -3. I'm going to color in my circle, make it solid because of that equal sign, okay? M is greater than. So I would shade to the right. Again, open circles for these 2 symbols, closed circles for those 2 symbols, okay? If it has an equal sign, it's included in the answer. So that's the basics of graphing inequalities on a number line. Okay, we're going to move on to something a little bit trickier, but still not bad. So do you guys remember the slope-intercept form? It is y equals mx plus b, all right? M stands for the slope, okay? Whatever number's in front of the x is your slope. The number hanging out at the end is your y-intercept, where the line crosses the y-axis. So we're going to need that when we start to graph inequalities. All right, let's look at a slide together. When graphing inequalities in slope-intercept form, less than and greater than have dashed lines because the number is not included in the answer. Less than or equal to and greater than or equal to have solid lines because the number is included in the answer. So less than and less than or equal to shade below the line, greater than and greater than or equal to shade above the line. All right, so that was a lot of information, but I promise you that we will go over it on our next few examples. So this time, we are going to solve some equations, we're going to make sure they're in slope-intercept form, and we're going to graph them. So our first example, okay, let's get these out of the way. Our first example is y, bad marker, just not having any luck. So y is greater than x plus 3, okay? Y is greater than x plus 3. I want to shade this on my graph, okay? So I'm going to make myself a graph, all right? Okay, so I've got myself a nice little graph. Remember, we have our y-axis and our x-axis. So going back a few lessons, we always plot our y-intercept first, which happens to be 3. So up on my y-axis, I'm going to plot a 3. The slope is 1. There's an imaginary 1 right there in front of x. So that means I go up 1 and over 1. Remember, you can write any whole number as a fraction by putting a 1 as the denominator. And then the rule states, if you have a greater than or less than symbol, your line is dashed. So I would connect those 2 points with a dashed line or a dotted line. And I need to shade in the answer, okay? Y is greater than. Well, if you're greater than something, you're above it. So I would shade above that dashed line. And that's what that inequality would look like when you graph it. Okay? All right. So let's move on to our next example. Okay? Let's look at our next example. Our next example says that y is less than x minus 1. Again, I wish I would have left that graph there, but I didn't. So I'll remember for the next time. So I'm going to make myself a graph. Okay, so my y-intercept is -1 this time. So I'm going to plot a point here. My slope is still 1. I go up 1 and over 1. My symbol is less than. Okay, it's still going to be the dashed line because it does not include that equal sign. It says it's less than. Well, if you are less than something, you are below it. Okay, so you would shade under that dashed line. Okay, so that's how you would graph the inequality on our coordinate plane. Okay, y is less than x minus 1. All right, so hopefully you're catching on, and this is not too bad for you. Okay. And actually, I'm going to have to draw a new graph every time we do one of these, okay? They get pretty sloppy. Let's look at our next example. -x plus y is greater than or equal to 8. So what do you notice? Is y alone? No, it's not. We have to put it in slope-intercept form. And we can do that by simply adding x to both sides. Okay, did you see what I did? If I would say plus x, this is going to go away. I bring down my y is greater than or equal to 8 plus x. Okay, now it's in slope-intercept form. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I can even go a little bit bigger there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Okay. I'm going to add one more here. Okay. So our y-intercept is 8. Okay. So if I go up 8 units, I would end up being right here. Our slope is 1. Again, that imaginary 1. Up 1 over 1. What type of line would I have this time? Look at my symbol. It includes the equal sign. So it's going to be a solid line, okay? It would be a solid line. Not very straight, but you get the point. And it says it's greater than. So I would shade everything above that line, okay? If your equation or your inequality is not in slope-intercept form, you have to make it in slope-intercept form, okay? We've got another one similar to that. Okay, let's look at our next example. We have 4x minus 2y is less than or equal to 4. Okay, so let's take a minute and look at this. This time I have a couple of numbers hanging out with y. I need to get rid of this 4x. It's positive, so I'm going to subtract it from both sides. Whatever I do to one side of the inequality symbol, I'll do to the next. Okay? I'm going to bring my 2y, my negative 2y. I'm going to bring down my 4 minus my 4x. Why could I not join those? Because they are not like terms. And then I would divide everything by negative 2. And that makes me think of that rule at the beginning of this lesson. If you divide or multiply by a negative number, you reverse that symbol. So I know I've got to reverse my inequality symbol. It's no longer less than or equal to, it's greater than or equal to. And I would do the math. Okay, y is now greater than or equal to negative 2 plus 2x. So I'm going to make my graph. Okay, my y-intercept is going to be negative 2. My graph doesn't have to be as big this time, thank goodness. So I put a point at negative 2. My slope is 2, which is 2 over 1. So from here I would go up 2 units and over 1. What type of line would I have? Dashed or solid? Well, since I have the equal sign, it's going to be solid. So I'm going to keep my line solid. It says it's greater than. You shade above that line. And we've just now finished our 4th problem in solving inequalities. So remember, if your inequality is not in slope-intercept form, you have to put it that way. Thanks for watching Lesson 26. I know we covered a lot of information. Feel free to look at the slides at the end of the lesson or go back and watch it several times. There's a lot of information in this lesson. See you in the next lesson.